Module 2.1, Phase. Since sound travels in waves, there will be times that we want to compare the difference between two waves. One of the things we can compare is phase. In its most basic definition, phase is simply the difference in timing between two similar waves. For example, here are two sine waves. They both start at the same time, and their amplitudes increase and decrease at the same rate. We can say that these two waves are in phase. They have no phase difference. Here's another pair of sine waves. The bottom wave starts 1 millisecond later than the top wave. Aside from that, the waves are identical. We can say that there is a 1 millisecond phase difference between the two waves. We mentioned previously that sine waves and simple harmonic motion are related to circular motion. Imagine a car going around on a Ferris wheel. If you face it head-on, you will see the car going up and down in a straight line, even though the car is actually moving in a circle. If we look at the path of the car over time, what will the path of the car look like to you? It will look like a sine wave. Now for a quick trip to high school geometry land. Hopefully you remember that a circle can be segmented into angles. A quarter of a circle is 90 degrees, a half a circle is 180 degrees, 3/4 of a circle is 270 degrees, and a full circle has 360 degrees. Now let's compare the degrees of a circle with the sine wave created by the Ferris wheel car. The beginning of the sine wave would be 0 degrees, the first peak 90 degrees, halfway through is 180 degrees, the lowest point is 270 degrees, and the end, or the beginning of the next cycle, is 360 degrees. So we can use these degree markings as a way to say where we are in a cycle. We can also use the degrees to talk about phase. Here, the gray wave is phase shifted to the right of the black wave by 90 degrees. To determine the amount of phase shift, choose a point on one curve, for example, an upward zero crossing or a maximum peak. Then find the corresponding point on the second curve. Finally, measure the time or degree difference to find the phase shift. A few terminology notes. The term out of phase refers to any waves that are not perfectly in phase. Do not mistake out of phase with 180 degrees out of phase. Waves that have a phase difference of 1 degree are also out of phase. Waves that have a phase difference of 180 degrees will be mirror images of each other. Another term for 180 degrees phase difference is polarity reversal or polarity flip. We'll see later that adding two waves that are 180 degrees out of phase results in one wave canceling out the other. To review, phase is the difference in timing between two waves. Phase shift can be measured in units of time or in degrees.